And we are live again. Welcome back to the webinar series about Kotlin for the server side. And well, today we are back to the roots. We have Spring with Kotlin. We are going to talk about migrating from Spring MVC to Spring Reactive Stack with Nicola Frankel from Hazelcast. And without further ado, I'm actually going to bring him into the stream. Hey there.
Hello, Anton. How are you doing?
Hi. I'm good. I'm good. I'm by the way, I'm calling from Tallinn. Where are you from?
So if I want to be like in the general vicinity, I would say I'm from Geneva, but actually I'm living in France, very close to the border.
That's an inside joke, by the way. Whenever we meet, I always say, hey, like, how's the weather in Geneva? And Nicola is like, I'm not from Geneva. Yeah. Like, yeah, so today will be an interesting topic. People like Spring, people like Kotlin. Today we have both of them in one stream. And but before we start, let's have some fun, actually. Nicola, do you like Spring?
I love Spring. I'm a Spring fanboy, actually.
Yeah, I like it too. But do you like Spring with Gradle or with Maven?
No, that's not a question. That's not even a question.
Yeah, because on the streams, we always have this crowd fighting whatever the presenter is actually showing. Like last time it was Maven, then the Gradle folks were saying, why are you using Maven at all? And vice versa. Whenever someone using Gradle, there are Maven folks who think that, hey, Gradle is so complicated, I want to go back to Maven.
Well, I mean, I don't want to start the fight, but I have, well, I always have battle scars from some stories of using Gradle. So let's forget about them. We will, I mean, we can talk about it later in a less public audience.
Okay. Maybe one day with the beers when we are offline again. So we can actually start with the presentation. So tell me what is going to be about.
Well, you already introduced the subject. So today I want to tell you about, you probably are using Spring Boot, otherwise you wouldn't be in this talk. And most of the people, they use interactive, and perhaps there is some, well, interest benefit from going to reactive and then to coroutine. And this is what I want to present to you today.
Nice. So I think we're going to start now, but you have prepared a nice GitHub repository that we are going to share with the crowd in the comments just in a few moments. And as Nicola is presenting, I'm actually monitoring the stream, so please ask questions. I'm going to break in whenever I feel appropriate, or if I know the answer, maybe I can answer directly. So yeah, Nicola, the floor is yours.
Thanks a lot. Stay in the stream, please, Anton, because since 1 year or more than 1 year, I've been presenting to my screen, which is not super nicely interactive.
Sure. I will stay with you here. I want to be in the stream as well.
Thanks a lot.
If you think that my face doesn't look good, like too angry or something, that means I'm reading the comments. It's not because fine. You are doing something wrong.
I prefer angry faces at no faces at all, believe me.
Okay.
So hi, folks. I'm Nicola Frankel. I'm a former developer. That's 20 years since I'm working in IT. I still believe that I'm a developer, but it's up to you to decide if a developer advocate is still a developer or not. But I've been developing for 18 years. So at least I still have a lot more developer experience than developers advocates experience. Something important also, I'm not a reactive guru. So I taught myself reactive, and I believe that's really, really important to switch one's mindset. It's not easy. And this is the steps that I can help you with. I work for a company called Hazelcast. You might have heard about Hazelcast if you are working on a JVM. On one side, we have an in-memory data grid. You can think about an in-memory data grid as distributed data structures, such as maps, for example, and the other one is an in-memory stream processing engine, which is called Hazelcast Jet, but I won't talk about it today. So in 2014, there was this publishing of the Reactive Manifesto, and the Reactive Manifesto tells like four properties, four capabilities of a system to be considered reactive. The first, it must be responsive, meaning, hey, if you like send a request, you won't wait for 30 minutes. The second, it must be resilient, that, yeah, if something bad happens, and we all know that something bad will happen, then it will still be able to answer at some point. Then it must be elastic, meaning that it scales. Well, probably like the ideal would be linearly, but at least close to linearly. And finally, it is message-driven. And when I say message-driven, that means that no HTTP calls that like are synchronous, but message pacing. And when I say asynchronous message pacing, I don't know what the people had in mind, but I can probably infer that they were thinking about the actor model. And the actor model has been popularized by the Beam platform from Erlang's fame. And basically, an actor is like completely encapsulate its own states. It doesn't have any getters or setters, and you interact with it by sending messages. And then you get like a message queue, and the actor reads the messages one by one. So that's actually the actor model from the Erlang platform. And the people from the Reactive Manifesto, most of the writers or the endorsers were from Lightband and were actually thinking about the ACA framework. The fun part about that is that that's not the main model right now. The main model, and I don't know why, is reactive streams. And the reactive streams is also about asynchronous stream processing. And it's also about messages, but in a very different model. And the idea is that you still have this like kind of queue, but then you have one big event loop, and then you send requests, and then the events, they get processed by an event loop, and then they get dispatched by an event handler. So the question is, why should we do reactive? Well, I have one good reason in mind and one not so good reason that gets repeated over and over. So let's start about the not so good reason. You might think that, hey, let's do reactive because it's more scalable. Hey, and you know, this is like this guy saying, hey, say web scale. Everything needs to be web scale. Well, for most of the application, web scale doesn't exist. So if you already designed your application to be web scale when you need to handle 5 concurrent users, probably there won't be a lot of return over investment. So once you start handling 10,000 concurrent users, then you might think, hey, let's go reactive. We need to be web scale. That's a good idea. But until that time, I'm not sure. There is another reason that I believe makes much more sense, is that it's more cloud friendly. Like when you go reactive, you are actually optimizing your resource usage. Like if you run your infrastructure on premise, then you don't care about wasting CPU cycles because, well, the infrastructure is there, you already paid for it, you don't care that much. When you deploy your application on the cloud, well, you will be billed for every CPU cycle. So it counts, and waste is not really a great way. That doesn't mean that if you are using the cloud, you should be reactive, because there are some downsides that I will explain. I mean, this is the way that you can, before migrating to reactive, you can by yourself estimate whether you will get a positive return over investment or a negative one. And then in that case, probably don't do it. So as I mentioned, there are downsides of going reactive. The first one, and the hardest one, in my opinion, is the more complex mental model. When you do an API call, it's quite easy to understand. I mean, an API call is synchronous. You call an API, you put a breakpoint, you know when you get the response, everything is visible. When you use a reactive API, the API is just subscribing. And so what happens is very hard to trace. And you need to put everything in your head, which in my opinion is much, much harder. Then because it's asynchronous, it's harder to debug, of course. Also, there are some specific APIs. So if you have been using like classical Java APIs, probably there is one specific API that you need to use now. And of course, this API depends on the framework that you are using. So if you know one reactive framework and you go into another reactive framework, well, the concepts will be the same. And probably the API might look the same, but you must be careful because the semantics of some of the methods might be like slightly different, and it might come to bite you in where the sun doesn't shine. Also, if you have one call chain and you want it to be reactive, then every link in the chain must be reactive. As soon as you've got one blocking call in the middle or anywhere, then your chain is not reactive anymore. So you will gain a bit, but actually you won't gain as much as expected. And so this is the Reactive Streams API, and you can see like it's very, very simple. It's very, very abstract. You've got one publisher that subscribes to a subscriber. The subscriber itself has 4 primitives, unsubscribe, and you pass in a subscription. The subscription itself, you can cancel it or you can request like n items. And this is where you can see the back pressure. You can see it's actually the subscription that requests. And then you've got stuff to do when you've received an item, when you've received an error, or when you successfully complete the stream. And because as I mentioned, there will be some chaining, then you need something that is both a publisher and a subscriber, and that's the role of the processor. And those 4 building blocks are just the foundations of everything. And of course, if I tell you, hey, folks, now you start using your reactive streams and you build upon that, it will be a bit hard. You will take time. So there are frameworks that are built upon those 4 building blocks. The one that you use in Spring is actually Project Reactor. It's led by Pivotal or by VMware or by Tenzu. I never know how they're organized, but basically it's the Spring Boot stuff. Just remember that it doesn't depend on Spring. Spring depends on Project Reactor. So you can use Project Reactor without having any dependency on Spring. And the way it's used, there are the building blocks that I showed previously, and then you have those blocks, those additional blocks. So Project Reactors provides an additional layer on top of the reactive streams. And I believe that everybody know about those 2 So mono is either like nothing or one item, and the flux is a collection of, well, a stream, a flux, or X items. And if you are a Java developer or you know about the JDK, you might know that there are also the same building blocks in JDK 9. So there is a class flow with the previous building blocks: subscriber, publisher, subscription, and processor. And guess what? If you go on the Reactive Stream website, they tell it very explicitly that, hey, right now we are using this package, but as soon as the types in the JDK will be available, we will actually be migrating to them. This JDK 9 was published 4 years ago, and they are still using the package from org.reactivestreams. So I believe that it's a migration that will never happen. If you need to bridge between the 2 packages, there is something that is called flow adapters, and that lets you translate from the org reactive streams to the flow class. Just in case you need it, probably you won't need it, but just in case, it's nice to know. So I assume that you are all Spring developers, and you might know that with Spring version 5, the Spring framework now supports reactive types. And actually, there is a dedicated module or sorter or whatever project called WebFlux, and everything happens in this package. So if you want to start and you are used to Spring MVC, so is Spring MVC reactive? No, it's not reactive. How can you use Spring MVC? You can use Spring MVC with annotation for sure. And in the latest version, there is also a web API that is functional. So it's called WebMVC FN, FN for functional. Interestingly enough, you can also use annotation with Spring Webflux, and there is also a functional API. So there are many ways to actually use Spring Webflux, starting from Spring MVC. What I believe is that you probably start from Spring MVC with annotation. And what I believe is if you migrate directly to Spring Webflux with annotation, you will the mind will make it so that it seems similar, but under the cover, the engine will be completely different. And when bugs happen, it will be a mess because you will get back to your reflexes saying, hey, this is how Spring MVC works. So what I believe is that the migration path that is like the best is to start, well, from the same place, migrate to functional APIs, get comfortable with functional APIs, and then migrate from Spring MVC to Spring Webflux. That's what I would propose you. And if you don't agree, that's sad because my demo does exactly that. So I'm sorry. So I've talked a lot, and now it's time for some demo. So I will try to, well, show you some code. Let's start from the beginning. So here I have created a project on like start.spring.io. You can see I'm using the latest and greatest, and I will have a comment about it later because this version, this 2.5 version, brings some good stuff. I'm also using the latest Kotlin version. It's a simple application. I don't want to do too much, so I'm using Spring Boot Starter Data JPA for database access, Spring Boot Starter Web, because, hey, that's my starting point. I'm using Spring MVC. I will be using Hibernate with some second-level cache, because, as you will see, I will lose the cache at some point. And that's very stupid because I'm using an in-memory database, but that's just for the sake of the demo, because normally you would use like a normal database, Postgres, MySQL, or Oracle. But here, my demo is self-contained. I'm using H2, and I'm still using a cache in front. Again, you wouldn't do that in real life, but here I'm allowing myself to do that. The rest is nothing mind-blowing, is the normal Kotlin plugin, and everything was scaffolded by the Spring Boot Starter. I have my entry point, Spring Boot application, main function, and I have my code, and my code does the following. So I've created an entity, a person entity, ID, first name, last name, birth date, and because I've nicely configured the plugins, or let's say that the Spring Boot Starter configured them for me, I don't need to open the class, I don't need to provide an empty constructor. That will be done at compile time. I'm using the GPA repository from Spring Boot Starter Data JPA. So that means I can be lazy. I don't need to write anything. And then I have created a controller with two mappings, a mapping that returns every entity from the database, and a mapping that returns the entity I'm giving the primary key from. On the configuration side, I've already some data. So I have like 5 persons in my database. When I start, they will be inserted. And the application, again, nothing crazy. I'm using Hibernate because I want to have some caching. I want to be sure that the cache is actually used. So I generate the statistic, and then I've configured the cache to use Hazelcast. But again, that's not really important in that case. And I'm using Hazelcast. So I just provide the hazelcast.xml, Spring Boot will recognize it, and it will start a Spring Boot instance at startup time. So let's do that. Let's start the application and see how magical it is. I mean, it's really great. I have shown my developer skills. Now it takes a bit of time to compile, which is not that great. It would be great if it started a bit faster. And I will prepare my curl. So curl HTTP, no, not HTTPS, local hosts 8080 that /person/1. And I get the first person. Amazing. And now you can see that I'm using the cache. So the cache was empty, so there was no hit. I did a put because there was a miss. And if I redo it again, I've got a hit. So I have no interaction with the database, no statement. So crazy, it works. That's what I was expecting. Now, the second step is actually to move away from this traditional classical way of doing things to use the WebMVC FM. And to do that, we can see that we have changed our controller. So now we don't have a controller anymore annotated with REST controller. We have just a configuration class. And we don't have get mappings, we've got beans. And those beans, they actually do register this router function. And when you build a router function, you return a router function. And you can see that this is much more functional. So here it can read like, hey, when you get /person, you do this, which is actually exactly what I was doing before. And when I get one, you do that. But here I'm explicitly doing, hey, I will be returning a 200 with this body. And so this is what we mean by functional. It means it's less about, hey, let's have an annotation, and it will be handled by some Spring magic. And we expect it to be the right way because we read the documentation. Here, it's much more explicit. And some people like it, some people don't like it. Well, I'm not here to judge. This is just much more explicit. So let's see if it still works. That would be nice. If it doesn't work, then I'm in trouble for the rest of the demo because that is just a simple step. So let's get back here. Not here, but here. And let's curl again. And it still works. Okay, good. So because I restarted the virtual machine, the cache has been reset. So now the cache is empty, one miss, one put. And if I redo it again, we will check that it still works. Yes. So far, so good. We just moved away from the MVC annotations to the functional programming way, which, yes, still uses annotations, but like they are not related to Spring MVC, but just to normal Spring application.
So which one do you like more?
As I said, I'm not here to judge. Like the problem is, no, the problem is I'm old there, and you have white hair, and so I'm used to the REST controller and get mapping stuff. I'm used to that. Now I perfectly understand people who tell me, hey, but I mean, you don't know how it's handled. I mean, when you are relying on annotation processor, I believe that, yes, if you are not familiar with Spring, it can be an issue. So your mileage may vary. I don't care that much. I mean, I honestly now prefer this way because then I can put breakpoints. Whereas on annotations, I cannot put breakpoints. So that's the only thing that, I mean, if I have an issue, I would prefer the explicit way just for breakpoints. If you want to put a breakpoint on an annotation, it doesn't work, you need to find the annotation processor that handles the annotation. And in general, it's hard to find them. So in Spring, they are pretty, I think they are pretty explicit about it. Let's say download sources. I hope it works. So sometimes they, yes, no. So here, for example, they don't say which annotation processor will handle that. Or perhaps you can see it, but I cannot. Some of them, some of the annotations, you might find the annotation processor in the Java doc. But again, it's a weak link. You don't want to depend on that.
I wish there was a functionality where you can put the breakpoint to the annotation and the debugger stops whenever the annotation is processed. That would be
Shall
cool.
I open a bug, an issue in IntelliJ?
It's a feature request. It's not a bug.
Yeah. So it is as it is. So it still works. I'm happy about that, but I just want to use it the way the Spring team wants to do it. And how they want to do it is here, for example, I should put this in a dedicated class, and they call that a handler. So this logic, we should just factor it into a handler. It's nothing mind-blowing. It still is exactly the same. It's just that here, instead of like injecting a repository, we inject the handler, we create a handler, and we inject the repository in the handler, and the handler does the exact same thing.
So the handler comes from the framework, right?
No, there is no, actually, it's more of a pattern, I would say. You can see it, you don't inherit, you don't extend, you don't annotate. It's your own class, but it's how they propose you to do stuff. It's just to decouple the routes themselves from the routing logic.
I see.
And we shall, no, I was too fast. Yes, it still works. Blah, 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 still works. Let's check again. And caching still works. Yes, amazing. So, and right now we are at the place where we actually are using Spring Web MVC in a functional way. And it's the place where it's very, very easy to migrate to Spring Web Flux. So here, what I will be doing, first I need to merge everything into a single route. That's the benefit of Kotlin that we don't have in Java. There is this router function DSL. I forgot this step. And so we can have, you can have as many routers as you want. Probably you don't want to have like only one route per router. You don't want to put all the routes into the same router, especially if your application is big. You just modularize them how you want them to be modularized. So this is made possible by the router DSL, and it looks much, much nicer than the Java API. So if I believe that if you are Kotlin developers and you want to use this functional DSL, that's really great. It's much nicer than in Java, so just use it. It's really, really great, I believe. So now I'm finally at the place where I can migrate to Spring Web Flux. And it's like, as I said, at this point, it's very, very easy. I replaced the dependency of web by web flux. That's, well, quite straightforward. And I just changed the package. So it's not the same package because it's not the same jar, it's not the same dependency, but the classes, they are exactly the same. They have the same API. The only thing that I need to change a bit is I need to change body by body value. Why? Because now we are using these reactive types on the web flux port, and the repository still returns normal types. So we cannot subscribe. So that's what I told you before. At this point, it's only halfway there. So we have migrated the front part, but the data access port is still using standard types. Let's run it and just let's check that it works. And if you've got any question, just like Anton, don't be afraid to ask them. He will be reading in the chat that I cannot do because I cannot have one eye on my demo and one eye on the chat. But Anton is a super great proxy, so don't worry and just ask a question. I will do my best to answer them. So now I can curl again, and it still works. Amazing. And everything is still working. The cache is still working. Great.
There was actually a very good question, I think, and I think it makes sense to ask it now. So we are using JPA, we are using Hibernate. What about reactive part? Like, will
That's
Hibernate
exactly
work?
my next step. That's
Perfect.
Just in time. Vovремя. So basically, the problem right now is we have replaced Spring WebMVC by Spring WebFlux. So this port is reactive, and the database access port is not reactive. So our call chain is not reactive. But if we move to a reactive database access, now we need to change a lot of things. And when I say a lot, it's really, really a lot. So let's use Git for that, and let's see. So the first thing is, well, obviously, I need to replace my Spring Boot starter of Data JPA by Spring.R2DBC. Then I need to replace H2, which was accessed by a standard JDBC driver, by R2DBC. Then, since I'm not using Hibernate anymore, it makes no sense to keep using the integration of Hazelcost with Hibernate, which means that I don't cache anymore. I have no cache. I just let go of my cache, which is not that great, I believe. And of course, Hibernate was taking care of creating the schema. So now I need to create the schema by myself. And I mentioned before that Spring Boot 2.5 brings something new to the table. Before, I had to actually explicitly call schema.sql and data.sql at the beginning of my application. Spring Boot 2.5 detects them and will call them implicitly, so you don't need to do it yourself. On this side, sorry, I can directly go there. We just need to say, hey, enable R2DBC repositories. And on the repository side, now we have a reactive sorting repository. So we replace our JPA repository by this reactive sorting repository that returns reactive types. So actually, this is a mono. Like if I tell it here, if I know it, specified type. Yes. So now it's no more a person, it's a mono of person. And here is a flux of person. And now we can just call body, and this will subscribe to this. So now our whole call chain uses only reactive types, and our whole application is reactive. So let's just start and hope that I didn't do any bad stuff. I hope so. Again, if I do any bad stuff, it will be hard to debug it live, but let's curl it. Yes, it works, but yeah, no cache. No cache anymore.
So how do you go about it? Like, what's wrong? Like, can you get the cache back?
I can get the cache back, but I cannot get this Hibernate second level cache back. I need to write the cache by myself. Well, not write the cache, but call the cache by myself. It will be in the later step. But right now, I have something interesting that I want to show you. I tell you, hey, I've replaced the Spring WebMVC by Spring WebFlux. It's reactive. I have replaced the database access by reactive. I tell you, hey, everything is reactive. How can we be sure that everything is really reactive? I mean, either you have got very, very talented engineers, or you trust me, or
you use tools.
Or you use tools, and actually that's much less expensive than good engineers. So there is something called Blockhound. Blockhound is actually a super nice tool, and you install it at the beginning of your application, and every time it detects that there is a blocking call, it will throw an exception. And here I had to configure it further because for whatever reason, there was a blocking call somewhere. So I told it, hey, if you stumble upon this, that's fine, no worries. It's acceptable because there is no other way. I even think I created an issue, I don't remember. Now, if I start this application, we can make sure that there are no other blocking calls, actually. And let's see how it works. Yes, it still works. So now I'm sure that if somehow I introduce a blocking call, which is not in the random access file read bytes, it will be fine. And it will be quotes, and I won't introduce any blocking call in my reactive call chain.
What if you do? What if you do, like,
what
will be the output, or will the application crash, or what will happen?
I can unconfigure that. So I will just call install directly. And then, so I have this blocking call that shouldn't be blocking, but is blocking. And when I start the application, everything is fine. But if I curl, I will get a nice runtime. So here it tells me, ooh, you made a big, big mistake. And here I have this stack trace. And actually, I need to get to the top because it will be like subscriber, upon subscription, upon subscription, upon subscription, to understand where the issue was. And it tells me, hey, when you did this call, there was this issue. And as I mentioned, there was in the random access file, there is this read byte stuff. And we can see that it's reading a zip file. Why is it reading a zip file? Because it's doing some reflection. And well, so this is the ID. So that's why in the end, I decided, hey, I should configure it to forget this call because otherwise it doesn't work. I think it only happens on the first call. I can try it again. I don't remember. No, it doesn't happen just on the first call. So it's still doing some bad stuff. But yeah, I think in the bug, I got an answer that it was only called once. But in all cases, I have to configure it like this. And the good thing is, by default, it should be configured out of the box. You perhaps need to tweak it a bit more. If you have your own reactive framework, which, of course, I wouldn't recommend, you need to configure it yourself, saying, hey, this is an acceptable call in this thread, and this is not acceptable in a non-blocking thread.
Okay.
Now, the next point is actually, I want to add a new capability. I want to do something that I didn't do before. If I call an entity, if I request an entity that doesn't exist in the database, I want to return a 404. You might ask, why a 404? I have no clue. I'm not a REST expert. 404 means not found. I think it's a good idea. And so it brings us to the fun part of the API, meaning you cannot do if repository find by ID equals null, because it will be a mono. You can say, hey, if it's empty, but that's not really what you want to use it. What you want to do is to use the reactive style way of doing stuff. So here, repository find by ID will add a mono. And if the mono is empty, we will switch to another mono. And it will be a mono of error. And this error will be whatever, here 404. So what happens now is, sorry, if I run this, and I curl, but not too fast, otherwise it won't work. So not too fast. So this still works. And if I call 14, for example, I've got a 404. So when you start doing reactive, you should forget about your ifs, your whatever, which is exactly what I'm not going to do just now. I will re-add the cache. So what would be a Spring project if there wasn't any service layer? Every Spring project needs to have a service layer, or it's not a proper Spring project. Do you agree, Anton?
Kind of, yes.
So here I have added a caching service. And what this caching service does is it adds a layer between the handler and the repository. And what I'm doing, I will check by myself in the cache if there is this person. If it's not found, sorry, I will search in the repository. And if it's found, then I will put it in the cache. If it's found in the cache, I will just wrap it in a mono and return it. And I do the same with the find all. And on the person side, it's still the same stuff. So I'm just using service instead of using the handler directly, the repository directly. Sorry. Let's start and let's see how it goes.
Oh, by the way, there was a good question. Like, why does this person handler get all actually return a mono instead of flux?
Because you don't return a flux of person, you return a mono of server response. Because you return not, I mean, that's the problem of being explicit, that you need to actually like conform to something. If you are using annotations, that would probably happen under the cover without your knowledge. Here you are being explicit. You say, hey, I return a mono of server response because, okay, here it's a body builder of server response. And when you call body, you return a mono of server response. And then you just pass the flux. So this will subscribe to the flux. Is it clear? Yeah. And now, so I was like, it was not found in the cache. It was put in the cache explicitly. And if I redo it again, now I have found it in the cache. But as I mentioned, that's probably not what you want to do. You don't want to do this with if and this. You should use reactive APIs when possible. So the next step is actually to just use the reactive APIs that I'm trying to sell you since the beginning. And it looks a bit different. But it makes sense. Not here, service here. Where is my service? Caching service, it's here. And yeah, like, buckle up your seatbelt because that's the part where it becomes a bit more involved. So the first thing is we need to check in the cache. We don't want to do that synchronously. We want to do that asynchronously. So fortunately, SLCast provides an async API, but it returns an old type called completion stage. So this is an old type from JDK 9, I think it's JDK 9. Let's be sure about it. Completion stage. No, JDK 8. So that's from JDK 8. That's a long time ago. So I need to bridge from this completion stage to mono. Fortunately, there is this extension, mono from completion stage. So now I have a mono. And do on next means, hey, if mono is not empty. And of course, here, that means that I will log if it's not empty. Meanwhile, I will start the application, then I won't waste time afterwards to wait. But if there is nothing, so this is my if else. If it's full, do that. If not, then get it from the repository. And if it's not empty, put it in the cache asynchronously again, and log the information. And well, find all is much easier because you don't need to check in the cache. You just need to put in the cache when you found it. So this is how it works. Person with ID 1 set in the cache. And person with ID 1 found in cache. So now I'm using the cache again. We can see that it doesn't happen on the main thread. It's completely async. We are very happy. But notice that no integration anymore with anything. I had to do that manually. So again, it's a trade-off. Perhaps in the future, there will be some nice integration with every async R2DBC access. Perhaps not, I don't know. But right now, you need to do that manually. And now the last step, which I believe is the best of the best. I actually have a hard time with this API. I must tell it, I must admit, it's really, really hard for me. In general, I know what I want to do, and I don't know the syntax. And the documentation is very huge. So what I do is I call my Reactor guru, and actually it's Oleg, who will be your next presenter. And I ask, hey, Oleg, I need to do that. Hey, it tells me, hey, you need to actually call this API. Oh, thank you. So if you are not an expert, it's really, really hard. Of course, you cannot be an expert and know an expert, which is the best. But if you migrate to coroutines, you don't care anymore. So my last step is actually migrating to coroutines. And then it becomes much, much simpler again. Like now, we can use what we know. So we still have our get async, but then we wait. And also, we can, if it's null, then it's not found. And then otherwise, it's found. And then if it's null, we find it by ID. But it can also be null, so we don't forget to use this. And if it's not null, then we put it in the cache. And it's so, so simple. There is just one thing that we need to do on this part is now we need to migrate this to a coroutine sorting repository. Because previously, our reactive sorting repository, it returns reactive types. We don't want it to return reactive types. We want it to provide suspending methods that return normal types. So here, when I have this stuff, we can see that it returns a person, a standard person. And now we can do, hey, if it's null, then return not found and call build and await, because we must return a server response. And if it's okay, then we use the body value and await. And same here, we have a flow and we say body and await. And in order to use the router, we have a co-router. So we have a DSL that is completely made for coroutines. The get here is a suspending function. And now it's, in my opinion, much, much clearer. I mean, if you are not a reactive guru, it's much better. If you're a reactive guru, not so much. But as I mentioned in the beginning, I'm not a reactive guru. So for me, this is much easier to understand. And under the cover, it's very, very similar. It's just a subscription. So now I can do the same. And we can see that here, person with ID 1 not found, it's put. Again, it works, it's found. And now if we load everything, so everything was put into the cache. If we ask for ID 2, it was found into the cache and returns. And I believe that right now we have, in my opinion, if you are a Kotlin developer, the best of the best. You have the readability, you have the classical mental model, you have blockhound just in case you made some big mistake that something was blocking and shouldn't be blocking. It's, I believe, like the nirvana that you can achieve.
It feels like there is a nice abstraction provided by the coroutines that covers the machinery of the Reactor from you when you don't want to get overflown with the complexity and with all the types and operators it's still there, it still works there, it still does the job for you, but there is an abstraction that hides the complexity with the coroutines.
Exactly. That's my point. I mean, I can read that, and of course, I don't want to do advertisement for IntelliJ, but it tells you, hey, this is suspending function. So you can still see what happens. So you know it's not like a normal call, but you can still write it like it was. And I believe that's super good.
Yeah. What I really like about it is how it's integrated with Spring. So it comes out of the box. It feels native to Spring, like it was designed for that, right? There is no like edgy places where you have to somehow, master something and put it together. But it's all provided out of the box.
I must say that for that, we need to thank like Sébastien Deleuze, who is a big Kotlin fanboy, and he provided this coroutine function DSL, and is also, I think he was working on the coroutine sorting repository, or I mean, at least he made people like really passionate about Kotlin. And so now we have a like super great integration of Kotlin with Spring Boot, so that if you're a Spring Boot developer, you are a Kotlin fanboy, you can have the both of the best.
Exactly. So kudos for Sebastian.
Yeah, definitely.
Perfect. Let's see what are the questions in the chat. So there were questions and discussion about block count, whether it's designed for use in production or just for testing. Yes, yeah, I agree with you. It shouldn't be used in production. I think it should be used in tests, in your integration testing, in performance testing. You figure out that there is a blocking call, and you remove it, and you remove the agent in production. Right?
Yeah, exactly. I will just finish my slides so I can have my sum up, and then I can give all the references. So this is my summary. If you are using Spring WebMVC, just migrate to functional APIs first, just to realize it's a different coding model. Once you start migrating to reactive, everything needs to be reactive, or you will be losing a lot of the benefits. And for that, just use block counts. It's definitely more work, but nothing is impossible. Again, if you are using Kotlin, coroutines, I mean, it makes it much, much easier to understand. And if you remember one thing from this talk is, don't use reactive because I tell you to, or because others do. Use reactive because it brings you return over investment. And in most cases, it won't. So please evaluate it carefully before you dive into that. So thanks for your attention. You can read my blog. You can follow me on Twitter. Here is the GitHub repository. And if I got you interested in Hazelcast for whatever reason, you can join our Slack and get some free training. And now it's time for some questions.
I think there was a very interesting question regarding the design of Reactor system. Is like, what happens, or like what will you actually experience or lose if some of the parts in the chain are not reactive, are blocking? What will happen? Like, well, there will be some sort of memory consumption, higher memory consumption, or anything else?
I think that you could think about like a reactive, a call chain like a stream of water. And so if it's reactive, the water flows. And if you have something blocking, well, you just cut the flow, do some stuff, and open the flow again. That's how I would reason about it.
So eventually you will lose the messages or will lose some data if it overflows, right?
That's not what I said. Well, the first thing that you must understand is a lot of people tell about back pressure. So back pressure is the ability that for a subscriber to tell the publisher, hey, give me like X items. I'm ready to process. Okay, imagine we are in a fully reactive system. Now we have a slow subscriber and a fast producer. Slow consumer, fast producer. Okay, so the producer will produce and produce and produce, but the consumer won't consume as fast. So in that case, back pressure is nice, but it won't solve all your problem. There are only two ways to solve this. Either the producer buffers, and the buffer is limited anyway, or the producer discards.
Yeah.
There are no other ways. So thinking that, hey, I will be reactive, everything will be fine, I won't lose any data. No, not at all. It will make your system under load more resilient if you have peaks, and then it goes down back to normal. But if you constantly increase the load, it won't be magical.
Yeah. Everything comes at a cost, and everything has its own
trade-offs
limits.
everywhere.
Right. All right. I think we are done today, and that was very interesting session. People liked it a lot, and folks, leave us more comments. What would you like to see in the next sessions? And subscribe to Twitter for Nicolas, and of course mine as well. Like it's here, right? It's here. And so good luck, everybody. And it was a pleasant experience with migration from Spring MVC and to Reactive. So good luck, and thanks Nicolas, for coming.
Folks. If you were too shy to write down your questions, my Twitter DMs are open. And last week I had the same talk in Java, and there was a question about Blackhawk. I couldn't answer on the spot. So I did some research, and now I have a blog post boiling. So if I cannot answer a question, and it's an interesting question, be sure that I will try my best to answer it, even if I don't do it directly. So thanks for invite, Anton. I hope to see you in person soon, and everybody take care, and also see you soon. Bye-bye.
Bye-bye.